Example 42. Now, in example 42, we're told to let y be equal to 3x to the fourth power minus 4x to the third power minus 12x squared plus 8. We're asked to A, find dy by dx. B, find the coordinates of the stationary points on the curve. C, to classify the stationary points. D, to find the points for which d2y by dx squared is equal to 0 and classify these points. And E, we're asked to sketch the graph of y. So let's start off by doing A, which is to find the coordinates, which is to find dy by dx. So dy by dx would be equal to 12x to the third power minus 12x squared minus 24x. So that is A. Now B says that we are to find the coordinates of the stationary points. And so we know that at maximum and minimum, that's where you have your stationary points. Dy by dx is equal to 0. So therefore, 12x cubed minus 12x squared minus 24x is equal to 0. 12x is a common factor. 12x outside the bracket. Then we have x squared minus x minus 2 is equal to 0. Now, if I'm multiplying two things and I'm getting 0, which is either the first, which is 12x, that is equal to 0, or the second, which is x squared minus x minus 2, that is equal to 0. All right, so if I divide both sides over here by 12 and factorize over here, we'll have x here and x here. I'm going to have 2 here and 1 here. This is going to be negative here, and right here is going to be positive. So therefore, I'm going to have x is equal to 0, or x plus 1 is equal to 0, or x minus 2 is equal to 0. So therefore, x is equal to 0, or x is equal to minus 1, or x is equal to positive 2. So we're asked to find the stationary point. So these are not points. So what we have here are the values of x at the stationary point. So next I'm going to say when x is equal to 0 and y is equal to 8. So that's coming from the polynomial. When x is 0, everything in the in y is going to come out to be equal to 0, but 8 at the end. So one stationary point is the point 0, 8. So 0, 8 is one of the stationary points. All right. Could go back a little higher. Well, we could come back here and maybe save some space. I could say also when x is equal to minus 1, y would be equal to 3 minus 1 to the fourth power minus 4 into minus 1 to the third power minus 12 times minus 1 square, and of course plus 8. All right. And if you put this in the calculator and press equal, you're going to get y is equal to 3. All right. So another stationary point is minus 1, 3. Minus 1, 3 is another stationary point. Next, I'm going to say when x is equal to, I'm going to say when x is equal to 2, I'm going to get y is equal to 3 times 2 to the 4th power minus 4 times 2 cubed minus 12 times 2 square plus 8. If you put that in a calculator, you're going to get y is equal to minus 24. And so 2 minus 24 is another stationary point. So we have all three stationary points. So at B, we're asked to determine find the stationary points on the curve. So we did. The stationary points are 0, 8, minus 1, 3, and 2, minus 24. So C, next we're asked to classify the stationary points. So now we're at C. We're asked to classify the stationary points. So let's start out with dy by dx. And that is equal to 12 x cubed minus 12 x squared minus 24 x. To classify the stationary points, I'm going to use the second derivative test. So then I say d2y by dx squared, and that will be equal to 36 x squared minus 24 x minus 24. All right. So the next thing I'm going to say is when x is equal to 0, d2y by dx squared would be equal to minus 24, which would make it less than 0. If it's less than 0, it means that at x is equal to 0, the curve concaves down. If it concaves down, it means that the point 0, 0, 8 is a maximum turning point. I'm going to also say when x is equal to minus 1, d2y by dx squared, when x is equal to minus 1, that would be equal to 36 minus 1 squared minus 24 times minus 1 minus 24. All right, and this would be 36 minus 48, which would make it negative, which is less than 0. If it's less than 0, it means that the point minus 1, minus 1, 3, point minus 1, 3 is another maximum turning point. All right. The fact that it's less than d2y by dx squared is less than 0 means that it concaves down. If it concaves down, point is a maximum turning point. Now, when x is equal to 2, d2y by dx squared would be equal to 36 times 2 squared minus 24 times 2 minus 24. So if you work this out, I'm sure it's going to come out to be positive, which is greater than 0. So that makes the point 2 minus 24, because this, if it's greater than 0, it means that it's concave up. So this is a minimum turning point. So at 2 minus 4, the curve concaves up. So 2 minus 4 is a minimum turning point. Now we're at D. At D, we're asked to find the points on the curve where d2y by dx squared is equal to 0. So d2y by dx squared, which is equal to 36x squared minus 24x minus 24 is equal to 0. So divide the entire thing by 12. If I divide the entire equation by 12, I'm going to get 3x squared minus 24, minus 2x minus 2 is equal to 0. All right, this can't be factorized. So because this can't be factorized, we're going to have to use a quadratic formula. It means that x is equal to minus b plus or minus the square root of b squared minus 4 times a times c all over 2a, which is 3. So this is going to work out to be 2 plus or minus the square root of 4. Negative times a negative is a positive, and this is 24. And this is all over 6. All right. So this is going to work out to be 2 plus or minus the square root of 28 over 6. This will be 2 plus or minus 2 root 7 all over 6. And this would be, divide both the numerator and the denominator by 2. You're going to get 1 plus or minus 7 over 3. So therefore, x is equal to 1 plus root of 7, it should be the root of 7 here, over 3, or x is equal to 1 minus the root of 7 over 3. So at these values of x, d2y by dx squared is equal to 0. All right, we could say here that this is approximately 1.2, and this is approximately minus 0.5. All right. So what's the next thing we're asked to do? The next thing we're asked to do is that we're asked to classify these points. All right. So I'm going to actually stop it here and continue the rest of the question in the next video.